Number 9 says, in the figure shown below, E and G lie on segment AC, D and F lie on segment AB, segments DE and FG are parallel to segment BC, and the given lengths are in feet. What is the length of segment AC in feet? Go ahead and pause the video and try this problem on your own first. So before we start working on this problem, I just want to mention that really most of this you don't need to read. And I'm not trying to upset any of your geometry teachers, because they probably told you that you can't just look at a diagram and assume anything. But the ACT isn't really out to trick you like that. So we are going to kind of assume some things. We don't really need to read most of this. It's just asking, what is the length of AC? All right, so let's take a look at AC, which is this whole line segment here. And what we need to recognize is that we have a whole bunch of similar triangles. So there's the small one here, and we can tell that from the left side to the right side, we just have to multiply by 2, right? 8 times 2 is 16. And that's going to happen in all of these triangles. So I could highlight this one, like from A to F, this middle, or this like medium triangle, be the same thing. Now we're not going to just multiply 7 by 2, because 7 is just part of this little trapezoid down here. What I actually want to do is multiply all of this by 2, and that would get me this whole line segment here. But actually, I don't even care about that triangle. I care about this big triangle from A to B, and from A to C. So from A to B, if we add 8 plus 7, that's 15, plus 6, that's 21. So this whole line segment on the left is 21. If we multiply that by 2, that will give me the whole line segment from A to C. 21 times 2 is 42, so the answer is D. And the ACT categorizes this under, of course, geometry.